All right, everybody. We are back with the Infix to Postfix program. So right now, I am here. I'm going to be doing most of the talking, but Aaron is here and he will help go over some things and ask some useful questions.
Hello!
All right. So I'm gonna, as you can see, I have two classes. I have the Infix to Postfix, which is our main central class, and then I have a class singly linked stack, which is my own, or I guess what would be your local version of the java.util.stack, which he said we're not allowed to use. So I made this version, which I'll go over that. As I basically used the last assignment singly linked list to make a stack out of it. So a lot of this should be familiar to you. Private node head is null. We're just creating an empty head. And then we have a few different things here. We have our constructor for the node, which I'll go over in a minute. We have public void push, which is putting an item onto the top of the stack. Pop, which returns the value at the top of the stack and removes it from the stack. And we have peek, which I realized we needed as going through the program. I'm like, this would be something that would be useful to have. I got that idea from Zach. Shout out to Zach. And we got, that one is basically just telling you what the number is at the top without actually removing it. So it's very similar to pop, but it doesn't actually take the value out of the stack. And last, and I guess least, it's not that important, but Boolean is empty, which just checks if it is an empty stack or not, and returns true if it's empty, false if it's not. That one's so simple, I'll go over that real quick. If the head is null, you return true. Else, you return false. It's as simple as that, because the head is the first thing in the stack and everything else is on top of that. So if the very first thing, which would be the bottom, is empty, there's nothing there. It means the entire stack is empty, and you return true, meaning that it's empty.
Yeah, because whenever we do a single linked list, it has to have a head. If you're starting at an element, like if you have a list, even if you go 1, 2, 3, 4, 5 instead of 0, 1, 2, 3, 4 or whatever, there's still a beginning to that list. The head is just saying, okay, yeah, there's something there.
Yeah, and some people might be confused with the idea of like what null means in this sense. These are of the specific item class node, or which is our own item type, which I'll get to in just a minute up there with private class node. But it simply means that there's nothing there. It's not that the values are 0. It's not that the values are null. It's that doesn't even have like a location in memory. It's that empty. So let's look into that. Let me close the is empty function and let's look at the constructor for the node. This should look very, very similar to what we were. Oh, it's actually the class for the node. There are two constructors within it. I think I said that wrong earlier. This is the class node, which is a private class. You could have this class outside as well, but that would make it confusing, so I chose to make it a nested class within the class singly linked stack. But again, this is very similar to what we had on the singly linked list. We have an item value, node next. It's the value that we're looking at, and an arrow pointing to the next item.
The biggest change that we made in this private class node, as opposed to the one that we went over whenever we did a single linked list, is that we've added a second constructor.
Yeah.
This constructor still uses a generic type for value. We didn't want to make it specific just for stack, so we decided to do that. It basically just says, okay, well, if you're going to give me these two things, I'll just go ahead and set it equal to it whenever I'm creating the node.
Yeah.
So
what this does is it allows us to just add another node, or it makes stuff in like bypassing nodes easier, so you can just point to a node further on. It takes away some complications, but it's not 100% necessary, but it was useful. So let me just go over these very similar functions, push, peek, and pop. They actually, we realized, were very similar to some of our functions with singly linked list again. So they might look similar to you with what we're doing with a node, temporary node. You're taking the value from it and setting it equal to what you're pushing onto it, and then you're setting that new head to be that temporary node. So you're creating a node, and then you're putting it at the new place of the head, which is the top of the list. Yeah. And then If it's not, well, oh yeah, that's the case if it's empty. I'm sorry. If it is empty, you have to create a temporary node so it makes it the bottom, and you actually fill the head value. If it's not an empty list, it means there already is a head. You simply change the head, and you make a new node with thing, point it to head, and then set head equal to the temporary. Any questions that would make that clear? I feel like that was a bit.
Basically, as well, what we're doing in the code, as you can see, we only made 2 constructors in Node, the one that's completely empty and the one with both parts. If you wanted to make this even simpler, basically what you could do is I don't know how useful it would be in the long run, but for this, it might make it simpler. You could make a constructor where you only give it the value and not the actual path. So that's pretty much what that's line 153 is saying. Temp.value is equal to thing. That's basically just changing the value in temp from nothing to something.
And the thing is whatever you're putting into the stack.
Yeah.
Yeah. So again, fairly simple, not too much going on here. As we get into pop now, it's going to look pretty similar in the structure of it. We have it, if it's empty, you return null. So we have a generic type item variable named value, which is just what you end up returning. We set it null at the start, so if it's empty, you can't pop anything, so you return null. The reason we have to do this is just for like technicalities, because you wouldn't really have this happen because you won't ever want to pop something from an empty stack, but it's just in case if you try to call pop too many times, it won't crash the program, it'll just return null. Then what you do is you set the value to the value at the head, and then if the next, so where head is pointing to, so the second one in the stack is empty, you set head to null. And if that's not the case, so if it's not only a head, if it's more than one item in the stack, you go ahead and just set head equal to head.next. And you move it on to the next one, which is simply how you remove something from it. And then you return the value that you got from the current, where the head used to be. So you take the value out from the head and then set the head to the last one. So the way that, if you're kind of confused with what the head is always the value at the top of the stack. So you're taking that value off the top and then setting the new top to the second, what used to be right below the top. Anything you want to add, Aaron, to that one?
Not really anything to add there. You pretty much nailed it on the head.
Popped it on the head. Peek is even simpler. You have a generic item type value, setting it to null. If it's empty, you return that value again, and it's null. And then there's not even anything you got to do here, because you just check the value at the head and then you return it. Fairly simple. It's not necessarily a function you need to have. The only reason we needed it is because it makes it a lot easier to do stuff we'll get to later when we're using it. You could pop it, get the value, save that value in a variable, and then push it back on top again and just use that variable, but we figured it'd be easier to just peek all the time instead of having to keep track of a bunch of different variables. And yeah, I already went over is empty. So that's all you need to know about our class singly linked stack of the generic type item.
One thing that I will say before we get any further into this is whenever we're using our stack class, as you can see, it has a generic thing in the arrow brackets.
Item. Yeah.
Item. Whenever we go to declare or create that stack object later on in Infix to Postfix, you have to put the data type that you're going to be passing it in those arrows. So it would look like, if you can pull up an example, I'm sure you have one.
This will be scary, guys. Don't worry. There's a lot of stuff. We'll go over it.
But if you look in line 12,
right here.
So as you can see, we have it in those arrows. That's basically changing in the original class everything that was item into string type.
So, yeah.
So don't forget to do that, because that could throw you in pretty big error and you not realize
So
it.
anytime you have a singly linked stack, in this case we're only using it one time because we're making one stack. At first I thought with the assignment we would need to have 2 stacks, but the only time you would need 2 stacks is if we were actually doing the arithmetic that he's, or the math, the actual calculation, but we're not. We're simply taking the input text and returning the output text. So let's get into how the main part of the program actually works. That was just a stack. This is where it gets a little fun.
Maybe
I just want to comment right now at the beginning we do have an import java.util.scanner. That's so we can collect the input.
Should we go over the littler ones first?
Literal. I was gonna go over them afterward, but I can go over them first. Do you think that would be better?
Or you could go over them while we hit them. So the first one that we come to that you've
that
created.
works. That works. We'll go over the functions as we get to them.
So
The different functions we have. So first you create the scanner, then you create a input string, and you collect the input from the terminal. And then what we do here is we're making and setting up our stack. I'm naming it the operator because it is a stack, and all we're going to be putting into this stack throughout the program is all of the operators. So plus, minus, multiply, divide, and power. You're not going to, I think, actually, wait, you might push some parentheses to it as well, but you won't push any numbers to it. You won't push the
sine, cosine, tangent.
yeah. Wait, do we push the sine, cosine, tangent? I think we might.
I think we do.
I think we do, but it won't be taking numbers or variables, so it's not taking everything. Not everything goes there. Where the other things go, as opposed to going to a stack, is to a output queue. You could call it the output string. I just call it the queue because you're using it not just as the output. You're also keeping track of the different things on it as well. So then what we do is we have a temporary string, which ends up not being super temporary because we're going through it throughout the entire loop, but it's basically just splitting that input string into a string array, so we're able to go through it in a for loop and go through every single item in the input one by one. So look at the number, say it's like 3. Here's our, up top we have one of the input tests. So it would go and look at 3, then it would look at plus, then it would look at 4, then it would look at a divide or multiply, and it goes through piece by piece, and that's what this large for loop is.
And it's important to note as well that you are going to have to split this. Whatever you end up using, you're going to have to split it, just because the way that we are allowed to differentiate each term is on the spaces. So a space basically indicates the end of whatever was last and an upcoming to whatever is next. So if we had 23 would be together, and then there'd be a space after the 23. There wouldn't be one in the middle. So if we get double digit or triple digits, that's how we're differentiating it, is if there's a space in between it or not.
So yeah, that's a good point. I had originally thought about trying to do it using a character array, and that's exactly the reason it won't work, because you have to be able to handle the word sign or multi-digit numbers. So breaking it apart through every space, it just makes it a single string which has number 3 or the plus sign in it, and then we're able to handle that as it comes. So I broke down the if statement so you're able to see it all, because there's a lot of stuff in a few of them, and we'll go through it line by line. But first we take a new string, we're naming it token, and we're setting it to whatever that current index of the temp string array is. So our first round through, say we're going through this generic input, our first input will be 3. So that 3 is going to be our first token. And what this large, very large if statement does is it checks every single possibility of what the token could be through using different functions and different things, and will do with that token what it's supposed to based off of the shunting guard algorithm, which is provided in the description of the actual assignment. So the first thing that we check in the shunting guard algorithm, if you read it in order, it says if the token is a number or ID. So The reason that that's not here, and we start with function, there is a reason there, because I realized that that could easily be the else case, because there are tons of numbers or possible IDs that could be anything. So we'll check if it's anything else, like if it is a operator that we're using, or if it is a function like sign, or one of those values that do specific things that need to be handled in a specific way. If it's not, it goes to the pretty simple else case. And oh, I forgot I still have some debugging things in here. But there, it checks if the queue is empty. If it is empty, it just adds the token to it. So that would be the first run through, it'll add the token to it. If it's not the first run through, it adds a space and then adds a token so that the spacing works out well throughout the program. But basically it just adds that token to the output queue. So if it's a number, like we said, it doesn't go onto the stack, it just goes straight to the queue. And that is how it works in the shunting algorithm, because it says if the token is a number or ID, then push it to the output queue. That's exactly what it's doing right here. Alright, so let's go through the different options in the large, very large if, else if, else if, else if, else thing. Our first option is if it's a function. It's pretty simple. We have it is function and we're providing a token. So now that we hit this first of our list of functions that we have, I'm going to go down and show you the private static boolean is function. So we're providing it a string, which is the token that we're looking at. In this case, say it's number 3. We're providing it the string with the number 3 in it. So if the string is null, return false, because if there's nothing there, it's definitely not a function. If you're wondering what the functions are, they are sine, cosine, tangent, min, max, square root, exponent, and tangent h. Those are the ones provided in the description that he told us to do, so I didn't want to check for anything else. So if the provided string dot equals sine, dot equals cosine, any of those options, and if any of those are true, we have ors between all of them, so if one of those cases triggers is true, it goes into the if statement and returns true. Else, it returns false. So it's a pretty simple case here, where it just checks if it's any of the things we want it to be, and returns true if it is. So, let's see what happens if it returns true. If our thing is a function, in this case, say we're looking at 3, it's not, but let's say we hit something that is a function. What will it do? All it does is it pushes it to the operator stack, and that's it. This is debugging, which I should have got rid of earlier, but don't worry about that. It literally just takes that token, say it's sine. It takes that word, that string, which is sin, and pushes it into the operator stack as a string, because again, we set up our stack to be a stack of strings. So that's it for the is function part. Next we hit is operator. So before I get into the middle of that, let's check out what is operator does. Private static boolean is operator. You provided a string and it returns true or false if it is an operator. Again, it returns false if it's null. And this does exactly the same thing as before, it's just different strings we're checking. If it's a plus, it'll return true. If it's a minus, multiply, divide, or exponent, it returns true. Anything else, it'll return false. Again, fairly simple. You could do that in different ways, but that's the way I chose to do it in this case. And if it is one of those operators, it will go into this section of the code. Again, we have some debugging in there because I had some problems with it not going through stuff right, but I got it all sorted out, and I forgot to take the debugging out. But this is probably the most complicated section because we have a weird while loop here. And for the sake of spacing, it looks really weird, but all of this is the condition for the while loop. The only thing inside the while loop is simply adding a space and the current top or head of the operator stack to the queue. So what this does is, and what it's checking, it goes through and it explains most of it in the shunting yard algorithm, and it matches word for word. So the first part of the shunting yard algorithm in the while loop condition says there is a function at the top of the operator stack. That's what this first part does. What that means... Yeah, okay, that's a good idea. You can read it right here. Alright, yeah. If there's a function at the top of the operator stack, that means... Oh, it's gone. If the thing that you peek at the top of the operator stack dot is function. So we're calling that is function again. The word functions come in here a lot, but if whatever is at the top of the stack is a function, that's exactly what it says. So that's one of our conditions. Next we go to an OR. So what is this case for OR? Now, where is it saying here? There's an operator at the top of the operator stack. Is that right? I feel like there's spacing weird with this.
Bring it out more.
There we go. If there's an operator at the top of the operator stack with a greater precedence. So, now we're finally getting to the last of the three functions, which is precedence. Now I'm going to explain this one before I get back to the while loop real quick. In here we have a simple switch case, which again I could have done with a if-else type of thing, but I figured a switch case makes a little bit more sense because there are multiple different options which do the exact same return value, but there's multiple different return values. So again, if the string you're provided is null, in this case I'm returning an integer, so I just return 0. If that's not the case, you are creating an integer named return value, and then our switch is the value we're provided to check, and if it's a plus or a minus, it has a precedence value of 1, and that's what we return. It breaks and returns it. If it has a string which is a multiplier divide, it has a precedence value of 2. It breaks and returns it. I'll get to what these mean in just a moment. But again, 3 if it's an exponent, and if it's not any of those, it means it has a precedence value of 0 and returns it. That's just the default. That won't really happen because in any case we're checking the precedence. It should be of an operator, which is any of these 5 options. But again, we have the default as a backup.
In case it's been a while since you've used a switch case, because I definitely remember not caring about them at all in object-oriented.
Yeah.
The way that a switch case works is that you start with switch, and then in the parentheses you have the thing that you're going to pass the entire case. So it's kind of like a mini function in that regard. So then you have your open parenthesis squiggly line thing, and then you go to your cases. The way the case works is that you have case, and then you have an argument that you're going to check against the thing that you've passed the switch above. And the way cases work is that they do something called waterfalling, which means you can have multiple cases and then an indented part before your break.
Yeah.
And if one of them's true, it'll start reading up until that break. And then it'll stop reading once it hits the break.
So
and
if
go
it
out
is
the
a
switch.
plus, it won't just give up because there's nothing immediately after that case. It will look until the next thing that it's being told to do happens, which is this one. Or if it's a multiply, it'll go and it'll still hit the return value of 2. Even though it's not immediately following, it's not right here. But again, it waterfalls and it ignores any of the following cases and goes into the next indentation area.
And another point to note, in case it's not easily visible or tellable, is that after the case argument is passed, we're not using a semicolon, we're using a colon.
Ah, yes.
So that's an important thing to note.
And last, but definitely not least, you have to have a break in each case, because if there is no break, I believe it continues waterfalling, and then it'll go and it'll actually return the value of 2. If you didn't have this break in here, it would hit 1, and then it would go and hit 2, and then it hit the break and return 2. So you need that break in there. Now, if you want to understand what the different values mean, there is a link to a Wikipedia page, which I read a little bit on, but it simply handles where to put the different operators in the output queue. So, which is what we're doing in the while loop up here. So if the precedence of the current top operator is greater than the precedence of the token, you do one thing. If the precedence of the top of the operator is equal to the token, and the token does not have a precedence of 3, you do one thing. And the last case is if the operator, so the top of the operator stack is not equal. That's important. There's a exclamation point. So if the, whoa, don't move that. If the top of the operator stack is not equal to a opening bracket. So if any of those things, those combinations of things are true, it enters this while loop until they cease to become true. And all it does in there, I think I said this before, is it adds a space and then it pops, which remember removes. We're not doing peek here because you're supposed to actually now take this operator out of the operator stack and you're putting it in the queue, which means you're done. So when you hit that plus, it'll put it in the output where it's supposed to be, and you're not going to worry about the plus anymore because it's out of the stack. And then as soon as you're done with that, you then push to the operator stack the token that you're looking at now, which is whatever it should be. And then it's kind of confusing, but this is how it needs to work for the actual algorithm, to the shunting yard algorithm, I believe, in order for it to work. So these are the different options. Again, I'll say it real quick. If the top of the operator stack is a function, or the precedence of the top of the operator stack is greater than the precedence of the current token, or if the precedence of the top of the operator stack is equal to the precedence of the token, and the precedence of the token is not 3. And so this AND is actually on the entire thing. If this, or this, or this, and this, and this. Does that make sense? There is a, this ending parenthesis is on this one. So this, I guess it would make more sense to space it like this and this, because all of those things have to be true. Well, one of this, or one of this, or this, and this. It's a lot of complicated logic, but hopefully you can follow the parentheses here. Again, this closing parenthesis is opened at the very beginning, and then there's the AND following it, which means this is very important.
It looks much more confusing in Java than it actually is whenever you read the English of it in the homework. So I would recommend, whenever you get to this part, to just go ahead, go online, and convert what you're reading, like have it like side by side, and just type it out how you would in Java. That'll just be a lot simpler than trying to actually... Because
every single one of these statements, like this statement and this statement and this statement, is a direct copy of like this statement. It's just translated from what it's saying in English to what it's saying in Java. So it is a direct one-to-one correspondence there of what's going on. It's just kind of complicated. And that is it for the operator section of the if statement. Alright. Next thing that we have to do is if the token that we're looking at is an opening bracket. All you do here is you push it to the operator stack. Nothing else, nothing fancy, you just push it to the operator stack. Again, I had some debugging in there, but that's irrelevant. All you're doing is pushing that opening parenthesis to the operator stack. If it's a closing parenthesis, you don't need the debugging. I should have got that out before we did this. Oh well. This one's a little bit more complicated. While it's not true that the operator.peak, which is returning the value of the top, so the top of the operator stack is equal to a opening parenthesis. So you're going, basically, when you hit the end, the close of a parenthesis, you go through the operator stack until you hit where that parenthesis was opened. So you're doing all the things. It makes sense with PEMDAS because when basically you're going through everything inside that set of parentheses and doing all that right there. And then inside of that while loop, all you're doing is popping everything out of the stack until you hit, again, that opening parenthesis. And the spacing in there is to make it look nice in the output for how he wants it to be done. And then as soon as you're done that, you pop one more time, because you hit that opening parenthesis and you want to get rid of it, because you hit it and then it's not gonna, you don't add that back to the queue. It just simply popped off at the end. And the last case here, this one is in the case that it is a number or an ID. What an ID means is simply it's a variable like an X or a Y or some other thing which is not an operator, is not a function, and it's not an opening or closing parenthesis. That's why it is an else case, because it handles anything other than those things that we specifically are looking for. And all it does is it adds it straight to the queue with proper spacing. And then there is one little thing that goes on after this large for loop that we just finished. So if you read, again, let me bring this over here. That for loop is actually responsible for everything that's inside the while in the description of the shunting yard algorithm. So now we are outside of that, and it says if there are no more tokens to be read, you go through and you do this. While there are still operator tokens on the stack, this is just a little note for parenthesis problems. All you do is you pop the operator from the operator stack onto the output queue. So any operators that you didn't handle already, which would mean they were inside of a parenthesis. So anything outside parentheses at the beginning, you just slap on at the end. And that's what's going on here. While the operator stack is not empty, you go ahead and you pop off the operator stack into the output queue with proper spacing. And you system.out.print the output queue and close the scanner. So that is about it for what we've got going on here. Again, we already went through the different functions. Operator checks if it's any of the operators. Is function checks if it's any of the functions and returns true. Precedence returns an integer value for the precedence, which if you still are struggling to understand, I would recommend reading a little bit about it on the Wikipedia page provided in the description of the homework assignment. Besides that, I would recommend doing a few test cases. There's one provided in the description of the assignment, and there's also this one here which Zach was using to test it. I'll do a quick run for you guys if you want to see what it would look like. I will do Java. I believe it is already compiled. Actually, I didn't compile it without the debugging. So let's check this. Infix to Postfix .java, Java infix to Postfix. And then the reason I have a comment here is so I can copy that. Control C. There's the test input, and that is what the output should look like. 3, 4, 2 times 1, 5 minus 2, 3, exponent, exponent, divide, plus. That's what that one should look like. And at the spacing, it's fairly simple, just a space between each one. Trying to think if there's anything else I need to add. Everything in the stack I went over, everything in the infix, the postfix I went over. So yeah, I think that's about it for this one. If you have any questions, go ahead and leave them in the comments. We'll try to respond to them, or go ahead and contact us in any other way you know how.
Email's a good way.
Email works. Anything else you want to add about the assignment, about the code, or in general?
More in general than anything, we're sorry that this video is getting out so late. It's just very hard because whenever we try to do a video, we like to do the code together, because whenever we do it together, we can sit there and bounce ideas off of each other, and whenever we're doing it on ourselves, we're just trying to get it done, as compared to whenever we're doing it together, we're trying to understand more why exactly is this happening so we can explain it to you guys, as well as, okay, I did this in my code, but is that really the best way? And we'll sit there and we'll try to figure out exactly. So it takes a while, and we thank you guys for staying up and trying
to get it done.
Yeah, like keeping on us to get it done. But definitely from here on out, this is meant more to help you than to try and copy the code from. If you're working on it on your own and you just can't get it done, that's what this is for.
To help you as the last minute, you can get it done by following what we're doing. Probably this video is not even an hour. You could get it done in an hour easily.
Yeah, so try it on your own first, as always. But and then even feel free to email us at any time and be like, I don't understand this, even if we haven't pushed the video out for it yet. Like, if it's the day of, we might not get it out, so just go ahead and shoot us an email and be like, hey, I don't understand, can you come help me, or something.
Yep.
So,
and besides that, we'll see you
I'm
in
gonna
class.
start editing. I'll see you all later. Going to my
All
dungeon.
right. Goodbye. Recording started. You can cut. Can you cut stuff out? Right?
Come on, team.
Aaron, you can cut stuff out because it's already recording.
Yeah, stick your big.
You're gonna have to just cut to when I start talking about the actual part that we're gonna be doing. Can you do that? Can you handle that? Is that a yes or a no?
Yes. Yes.
Do you want me to stop the recording and go again?
Yes. Good job, team.
Aaron. Snap out of it. We're already half.
Good comeback.
I can cut it in the program.
I lost
Okay.
one objective time.
Start.
All right, Zach. We started the recording. We're about to actually go now.
You need to tell me they started recording.
Now we just did, and we're about to go. All right. All right.
Oh, I'm just kidding.
Can't with you, Aaron. 3, 2.
1.